Okay, welcome to lesson 6.1 on radian measure. We're going to start today's lesson with a warm-up on how to change answers into simplest form. Simplest form just means that fractions can't have radicals or roots in the denominator. We've already seen, we know that fractions have to be in lowest terms, that there can't be a negative in the denominator, that kind of thing. So to change, when you've got a root in the denominator, to change it to simplest form, our trick is to multiply the top and the bottom by the offending radical or root. So what I'm going to do with my first example, I see that there's the square root of 5 in the denominator, and I don't want that there, so I'm going to multiply the top and the bottom by root 5. And essentially, that's the same as multiplying the whole fraction by 1, and we know that when we multiply by 1, it doesn't actually change the value. So now I'm going to multiply across the numerator. So 1 times root 5, that just gives me root 5 in my numerator. And then multiplying across the denominators, I've got root 5 times root 5. So hopefully you remember from grade 11, multiplying radicals, that when I multiply two radicals, and it's the same type of root, so here I both have square roots, I can just multiply the numbers under the root together. So 5 times 5 gives me 25. And now I'm going to reduce this. I'm going to try to simplify this. When I look at the square root of 5, there's nothing I can do to simplify that. But when I look at the square root of 25, that's actually a number that I can square root. So I'm going to do that, and I get 5. And now my answer is in simplest form. So we'll take a look at another example. In part B here, I've got negative 15 over 2 root 3. So when I try to simplify this, the only part that's offending me, the only part that we don't like in simplest form is the square root of 3. So that's all I'm going to multiply by, just root 3 over root 3. I apologize for my handwriting. I'm getting used to a new tablet attachment. So I'm not multiplying by the 2. I'm leaving that there. He doesn't bother me, so I don't need to worry about him. Just the root 3. Now I'm going to take a look at my numerators, and I'm just multiplying across. I've got negative 15 times root 3, so we can write that all together without a multiplication sign as negative 15 root 3. And then I'm going to put that all over. And in the denominator, I've got 2 times root 3 times root 3. So we'll multiply those two roots together. So I've got 2. And then what I've got here is, you can write root 9, because I can put 3 times 3 under the root. Or you can think about it as root 3 times itself, so root 3 squared is another way to think of it. And then when I go to simplify this now, I've got negative 15 over root 3 in the numerator, or times root 3, sorry, in the numerator. And then in the denominator, I've got 2 times, and I've got the square root of root 3 being squared. So when I square a root, they cancel each other out, and I'm just left with the 3 there. Now, I also need to think about reducing this fraction to lowest terms. So what I've got here on top is 15, which I can also think about as 5 times 3. So there's a multiplier of 3 on top. And on the bottom, it's 2 times 3, so I have a multiplier of 3 on the bottom. So what I'm going to do is divide the top and the bottom of my fraction. I'm just reducing to lowest terms. So I'm going to divide the top by 3, and I'm going to divide the bottom by 3. And so what I get here on the top is negative 15 divided by 3. I'm just leaving that root 3 to the end. I'm not worrying about him right now. I'm just looking at negative 15 divided by 3. That gives me negative 5. And then the root 3 is just tagging along. And then in the denominator, I've got 2 times 3 divided by 3. So the 3 divided by 3 gives me 1, and I'm just left with 2. And now this is in simplest form here. There's nothing else I can do to reduce this. You could have done this differently. Like, you could have written negative 15 root 3 over 6, and then you could have reduced 15 over 6 to 5 halves. And then the root 3 would just be tagging along in the numerator. All right, our next example is root 2 over 5 times root 6. So it's really important to think about, well, what's the thing that I want to get rid of here to get to simplest form? All I care about is the root in the denominator is the one that's bothering me. So again, I'm only going to multiply the top and the bottom by the root in the denominator, the root 6. So I don't care about the root 2, he doesn't bother me, and I don't care about the 5, he doesn't bother me. And now I'm just going to multiply again across the numerator, root 2 times root 6, that gives me root 12. And across the bottom, the 5 just hanging out front, and then multiplying those two numbers underneath the root. 6 times 6 gives me 36. So this is, magic will always happen in the denominator, right? Because you're creating you're creating that root 6 in the second fraction in order that the new root will be a nice one to square root. So on the top here, I've got root 12, which I can simplify. When I look at root 12, what I notice is that 12 has a divisor that is a perfect square. So I'm looking for divisors of 12 that are perfect squares. And I'm going to rewrite 12 as that perfect square, 4 times 3. Remember, your perfect squares are just all of the numbers being squared. So the list of perfect squares starts with 1, 4, 9, 16, 25, etc. So I noticed that 4 divided 12. And then in the denominator, I can simplify. I've got 5, and then the root 36, that's just times 6. Now I can simplify this root in the numerator because I can take the square root. If it's multiplication in between, I can take the square root separately. So I'm going to take the square root of 4, that's 2. And then I'll take the square root of 3. Well, I can't take the square root of 3, so I still write root 3. And then in the denominator, I've got 5 times 6, so that's just 30. And then again here, I look for a reducing. So I'm ignoring the root 3 for a second, and I'm just looking at 2 over 30. That's the same as 1 over 15. So you can write the 1 if you want, but you don't need to. And what I did there was I divided top and bottom by 2.